This is section number 2 of 3 of the presentation that was given at ICOMIA's Marine Hybrid Symposium on a Global Perspective on the Marine Hybrid Market. My name is Cliff Denson. I'm the Director of Engineering at Brunswick Recreational Boat Group. This particular section will review Brunswick's alternative propulsion pursuits. I think it's important to give a glimpse of the methods that we utilize within Brunswick to develop a new product, whether it be a propulsion system, a boat, or even a piece of exercise equipment. Everything starts with an idea, and these ideas are consolidated and reviewed by our team at Product Development and Engineering and presented to a strategic portfolio management team, which determines if we meet the requirements to move forward in development. Now, if we pass that gate, we go through a process of refinement, market research, prototype, and validation before a new technology would be associated with a new vessel or a new product that Brunswick is creating. So we have to reasonably make sure that a new technology is viable from an engineering, manufacturing, and sales perspective before we would want to link that new technology to a model or a critical release date associated with that new model. For hybrid propulsion, our sister company, Mercury, has effectively led the efforts in understanding voice of the customer. Though individual brands such as Sea Ray, Princecraft, and Harris Chaot have both participated in and done their own voice of the customer research. So there's nothing on this slide that you probably don't already know, but this VOC research was simply focused on the ability to determine a level of interest of a new propulsion system, identify the overall system's likes and dislikes, areas of concerns as well, determine the relative appeal of various functions of the system, as well as determine the perceived value of the overall system. So you really have to know where you need to be to help you figure out where to start, obviously. The voice of the customer that occurred, the voice of the customer work that occurred on hybrids in particular was primarily centered around a hybrid concept vessel that was shown at Miami International Boat Show, February 2010. Here there were 31 different owners of vessels in the 30 to 54 foot range. Background information was collected on each particular individual that identified what boats they owned and what their interest was, in particular in new propulsion systems. There was a pre-test drive evaluation that was completed on board the vessel to understand expectations associated with a hybrid system. There was a test drive evaluation which captured the overall appeal of the system and the total functionality demonstration. And then there were some discussions around some ancillary power generation components such as a solar power system that was incorporated into this hybrid vessel. And finally, the overall purchase interest and perceived value was discussed. And this survey was completed after the test drive, really to evaluate the respondents' interest in purchasing a product and to identify the perceived price and value of the system. What I have here is a summary of some of the written comments associated with the quantitative data. The primary aspects of the hybrid system that was interesting to the individuals was how quiet it was. Obviously, its fuel efficiency and its total economy was a significant interest. And then there was also major interest brought up with respect to the ability to do without some of the common subsystems, such as a generator. Individuals here were alluding to the fact that because potentially you could get rid of one of these subsystems, the overall complexity of the system, though higher, was not as high because it didn't have as many subsystems. So some of the major concerns and dislikes of the hybrid systems that were brought up were obviously the cost and the quantity of maintenance. The fact that this was a bit vague at that point in time did not escape anyone, obviously. The overall life and expense associated with the batteries. This particular system had 48 lithium-ion batteries, and there was obviously concern about the maintenance and replacement of those from a cost perspective, and then overall perceived reliability. A lot of individuals were very excited about the project, but because it is effectively a new technology, there was concern there as well. This slide shows some of the quantitative data associated with the voice of the customer work that was done. The horizontal lines represent the importance of a particular attribute, and the vertical pie charts shows overall perceived confidence from the study group with with respect to the particular attribute. So you can see here at the top, the anticipated reliability was considered the most important, while receiving a relatively low confidence rating with respect to the overall system. Top speed was the least important, and it was understood and noted by the voice of the customer study group that this was not something that they were confident in being able to attain. In fact, it was not a particular attribute that was considered important anyway. If you look in the middle there at quietness, while this was a relatively significant attribute from an importance factor, you can also see that the confidence level was incredibly high because they were actually able to see an exhibit of that in the form of the prototype vessel that they were able to experience. To sum up the voice of the customer information here, you can see here on the left that the overall appeal of the system was incredibly high for all the respondents who were involved in the survey. However, over here on the right, you can see that a system that were to cost more than 20% over a current internal combustion system would dramatically reduce the overall appeal of the system. So from a target perspective, as we look at what a total hybrid system should cost, what we are saying is that if we develop something in the 5 to 20% premium range over a standard system, we will fall within the appropriate amount. Here's a quick snapshot of Brunswick's alternative propulsion technology projects over the last 5 years. Around 2008, Sea Ray's product development and engineering, as well as manufacturing technology teams, worked with Steyr Motor to integrate their powertrain into a 26-foot Sundancer. This project was one of many projects that was done in response to a customer base showing significant interest in green and responsible technologies. These projects spanned from significant volatile organic compound reduction to adjusted work schedules in order to reduce utility bills at our facilities. So in no way, shape, or form was the pursuit of green technologies limited only to new product development. This vessel was featured in publications and shown at a few dealer events to gauge interest, but was not developed as a production intent vessel. In 2010, Mercury adapted a 42-foot vessel to study the viability of hybrid technology coupled with their Zeus drives. You'll recognize this vessel as the one that was used in the in-depth voice of the customer research I discussed earlier. So this was obviously a significant technology innovation project and was led by a colleague of mine, Dan Baylog, Mercury's chief program engineer, responsible for the management of a number of critical projects, as well as obviously the organization's alternative propulsion pursuits. So to give credit where credit's due, Dan was instrumental in the construction of my discussion up to this point, and luckily was available at our symposium to field questions after the fact. Moving on to 2011, engineers in our freshwater division adapted and developed vessels to utilize pure electric propulsion systems with a solar battery power charging system. The motivation behind these projects was primarily driven by user interest in access to bodies of water that prevented the use of petrol or diesel propulsion. What Brunswick's working on today is in the upper right-hand corner. Unfortunately, the limitations of the method that I'm presenting this to you right now do not allow the animation that I was able to show at the symposium. But what that did effectively show was a 37-foot vessel that was developed in order to meet the challenging cost targets discussed before. This is a 37-foot vessel, like I said before, with stern drive propulsion systems and a interesting battery and electrical architecture system that we think is probably the direction that we're going to end up going if we pursue this further from a hybrid perspective. Now, I think that it's worthy of note that all research and development associated with these and many other projects was funded exclusively through Brunswick. I do envy the support that HIMAR has received by countries in Europe and do hope that that continues as we pursue alternative propulsion in